Hello everyone, in this tutorial we will create the pickup system that can pick up at different height, like from the table. The low table or the ground. And we add the widget to show where we can pick up. And this tutorial is part of the tutorial series about open door and pick up. So we will continue from this pick up item tutorial. Let's open door project. We go to project setting and set the SM6, set the model 6, D3D well, and enable this and restart now. In the last project, I used Unreal Engine 5.0 to create this system. So if you need to update to Unreal Engine 5.3, you need to go to Animation, Blueprint, to the control rig, and we need to update our control rig. Find it and open. This set foot control function. For Unreal Engine 5.3, you need to use this rig element key because the last variable, item variable, is not available. So change this and everything will work in Unreal Engine 5.3. Close. And next we will import our animation. I will provide the animation link in the description. So this is the same animation, but I modify it for different height of the location that the item that we will pick. Go to animation and drag this animation, grab animation, push skeleton is SK mannequin and import all. And then we go to pick up, then import this table. And we don't need to create new material. Do not create material. Import all. And go to third person, create new folder, name widget, import this texture image. If we open the person blueprint, and when we play the animation montage, we need to notify, select, add, and target. So this new animation, we need this notify too. Open this lifting And this is the target when we start to enable the control rig of the hand. And this when we collect the item. And this is the end of the animation. So this animation, let's create animation montage. Open it. Add montage notify. And the name is collect. And this, we add another montage notify. Name is target. And when we put the hand down, add another montage notify. Name is add. And create another any montage. This when we grab and notify, montage notify, select. And this when we love the control rig of the hand. Name is target. And add animation. Notify name, add. And grab for. Let's create any montage. And here is montage notify, collect. And we add another notify. Target. Then add. And save this animation montage. And we delete this. Delete this item. And this circle. And move this door back. Move this item here. And next move this player start. and go to this table. Use the first table and add this select item on this table. And let's play test. And when we grab this, we play the lifting animation, not grab animation. So go to third person character. First, we need to clean this project first by creating the function for some of these events. Add new function. The function name is get all item. And get items array and clear this. Then get sphere, get overlapping actor. For each loop, call is collectible. Then create a branch. And if it's true, call is valid. This array element is valid. Get item and add unique. Add this array element to items. And when we complete, return. Copy this item and return this. Name the output to return items. Compile and go to event graph. This get all items is used instead of this get if all item event, and this add collectible item. We can delete this. We delete this. And get all items. Next, we open this find nearest item. We need to change this variable to local variable because we want to call this function many times and it will not override the data of the variable. So this template, let's delete this and add new local variable. Name is template. And another one is temp nearest item. set this to actor. Then let's set this template. Set it to high value is 1 million. And we can delete this nearest item. Get template here, and we need to set this variable is valid here. And connect this vector length to this template. And we delete this nearest item. Use set temp nearest item. And this function at input. The input is items. And set it to array. And when we complete, call return, get temp nearest item variable, and connect to this return node. Rename it to nearest item. And compile and save this. Go to event graph. And we connect these return items to items. And call set nearest item. Connect this result to this variable. And let's save this. Next, I want to change this location and create this as another function. So click on this and right click, collapse to function. And change the function name to find walk to location. And set it to pure function. Open this function. And this walk to location, if the item is on the floor, I don't want the character to walk on the location of this item. It needs to have some space between the character and the item to reach and grab. So let's add another function. The function name is push item animation. And we choose the item animation depending on the height of the item. Add input. Variable name is item. And set it to single. Or is valid. Get actor location. And split this. Get actor location. Split. And we subtract. Get capsule component. You can drag it from here and get scale capsule half height. And we can subtract z with this. And this height of the item location. And when it's valid, create a branch. And this value, we compare it. If it is less than 30, connect to the branch. If it's less than 30, set the item position. So let's create another variable, item position, and set the variable type to integer. Set this to variable, and item position set it to 1. And in range, float, min is 30 and max is 60. And disable this inclusive max. We don't want to use the 60. And copy this. And set it to between 60 and 90. And another animation happens when it is greater than 90. And we create the branch. If it falls, and connect this. And copy this item position with true. Sorry, and this is false, and the true we connect it to the item position. And when it falls, the last one. And set the item animation to 2, 3, 4, and this is error. We can't find the animation location. So set it to -1. For return, connect to return node. Get item position and connect this to return. And we already finished this choose item animation. Compile, go to find walk to location. Add input is item actor. All is valid. And this item, we get the actor location. Then all get item from the input. Choose item animation. and equal. If it equal to 1, it means that the animation is lifting the item from the floor. And not Boolean. If it's not equal to 1, it means the item is not on the floor. We call select. Choose this select. And use this location if it falls. And copy this item. Get actor location. And use this location if it's true. And return this value. Connect it here to the return. And this capture component height, we want to get actor location, split this, subtract this z, and connect it to z. Because we want the system to work when we put this item on this different height, like on this static mesh, so it can calculate the animation that we should use. And let's compile, close all of these functions, go to event graph, and find walk to location, get nearest item, and connect it to the find walk to location. Copy this and connect it to this point move to location, and set this radius to 2.5. We want to debug the path that the character walk to, so add another function. Name is debug path. Add variable. The variable name is path points, and set this to vector and set it to array. Get path points or clear, and add input. Name is path add, the add location. So vector type, find path to location synchronously, connect to path add, get actor location, set it to path start, and we get path point from the result. Set to path points variable, and call for each loop. We draw debug sphere. Draw debug sphere. for this location. Radius is 5, line color green, duration 10, and thickness is 10. Let's save this, compile, and we call this debug after we move to location and use this find walk to location as the add path. And we can adjust this rotation rate to 180, and this one is 240. Let's compile and save and press E. Now we can see the debug and everything is working correctly like before. Next, we need to change this animation montage depending on the height of the item. And before we change this, let's copy this, select items, set it to false, and set it to false after we call the add notification. And this one, we delete this. And next we add the table, this low table, add it here, can move it here, and this high table, and we add this select item on the table, and this one, and this low on the ground. Let's see the name mesh, and we can see that this table we still can work on it. So go to project setting, all setting, search for nail, and this ceiling height, that is to 8, this one to 8, and this height to 8, and this cell size we can adjust it by divide it by 2, and this divide by 2, and divide by 2, and let's save this. And we cannot work on this table now, can move it near this. I think this gap is too far. We can adjust it by go to this table and open, show the simple collision, click on it and to scale. I want to scale it a little bit smaller than actual size of this table. It's too much. Set it to 0.125 and scale this. Save. Open another table. Do the same. And another table. And save. Now this boundary is changing. Open third person blueprint and this animation montage. We get nearest item, choose item animation, subtract this item position by 1, and we select montage. Use this index because this index start with 1, so I need to subtract it with 1. And add pin. We have 4 animation. Go to animation. The first is lifting animation, the original animation. Scan, grab 2, grab 3, and grab 4. And connect to this play montage. We can play test now. Let's go to this location and walk through it. And we can grab. And we need to adjust the hand to grab at the right location. Close this project setting and go to third person character. Go to ABP menu. Go to event graph. First, I want to adjust this. The select trace IK. The target set it to 0.92 to lower the strength of this leg IK when we turn the animation. The set trace hand item need to add another variable. The variable name is item position. And set the variable type to integer. Set this to 0. And set this to the item position. We go to this event set trace hand item, double click, and this function. Let's add another variable. Input is item position. And set the variable to integer. Compile and save. And connect it to item position. add this IK hand trace item. We want to change this. We want to change this adjustment of the character and IK location depending on the animation of the item position. First, we select all of this and collapse it as a function. Name this function to door handle transform. We can move this mesh to here and select all of this. Right click, collapse to function. The function name is select all item transform. And we can connect it to here. This blueprint looks cleaner than before. And move it here. And we open this function. And change this name to item transform. Change this to character transform. Add variable. The variable name is scalar array app. Name is variable type is float and array. Duplicate this. Control D. Name is scalar array right. This is the right vector adjustment. And scalar array forward. And we can set this category to adjust position. Change this to adjust position and this too. And we compile. And this character get actor up vector. This is the right vector and this is the forward vector. And multiply. Convert this to float. And we add another pin. Add it here. Convert this to float. Remove pin. So this is the position of the item. And we want to adjust it with the vector up, right, and forward. And this adjustment value, we store it inside this array. Get reference and this item position. First one, get this position, and this forward. And position, and we can compare this, and this scalar array up. We have 5 animation position. The first one is when we open the door, and the second one for lifting the object from the ground, and this 3 is different height of the table. So we can add 5 element and adjust 1 minus 30, 13, 13, 13. This scalar array right, we set it to 7, 1, 7, 7, 7, and scalar array forward is 8, 12, 1, 1, and 1. You may have a question that how can I get this value? This value we get from when we play the animation, because we need to adjust the hand of the character. So if you want to move up stronger, you can adjust this index value to high value. And if you want to move it down, it's negative value. And if you don't want to adjust it, set it to 0. And this one is when we adjust it to right. We go to third person character, and this index position we not yet call set this value for the set trace hand item. This function send the variable data to the animation blueprint. So we need to set this item position and this one. Let's play test. Now we have the correct position. Sample this one. Is it correct? And I want to adjust this scalar array forward. This one set to 5. For the low table, it's not accurate. Now it's accurate. And we have some problem. We want the character to walk to pick the object, not run to pick it. So we need to adjust the box speed. Go to third person character and add function. The function name is adjust make box speed. Sorry. Get trace and create a branch. Get actor location. Get add points. Get a reference. Length. Subtract it with 1. Get another reference and copy this. Subtract it with 2. Find the distance between this and this one, distance. Less than. And another one. Less than 100. And call all boolean. Create a branch and connect when it falls. Get character movement. That makes walk speed. If it's true, we set it to 500. And if it falls, we don't set it. Connect this to return. This function, we want to set the speed of the character to 500 when we nearly arrive at the location of the item. So go to event graph and go to event tick. This collect item. After this branch, we call sequence and set adjust max speed. And when we pick up this item, we need to set this to lower speed for the character to walk. Set max walk speed and set it to 230. And we need to initialize the path points of the character that need to walk to the item. get actor location, get nearest item, find walk to location, find path to location, and we get path points, set path points, and connect it here, and connect back to this is valid. Compile, save this. Let's play. And now the character walk to the location and pick up the object. I want to prevent the character from pick up the item when the item is blocked by the static mesh and when the item is far away from the hand reach. So let's add function name is blocked by mesh. Input item actor, get actor location, break this vector and make vector get capture component, get scale capture half height, add it with z, and get actor location from item. And call line trace by channel. This is the start location and the end location. And I want to debug it for duration. For return. Return value. Add another function. Name is reachable. To event graph, copy this at points and connect it. Add input. The name is item and get actor location of this item. Get the length of at points. Subtract it with 1. It is the last point of the add point and get a copy. Use this index. Break vector. and break this vector too. Make vector, and we only connect this x and y. And find the distance vector between these two locations. And if it's greater than 65, we return. And return this boolean. And let's add macros. The name is Canvas tool. Input nearest item. Vector. Add another. Move it up. Change to execution pin. Change this name to execute, so we don't have this name on here. And it's valid. Call block by mesh. And connect this nearest item. When we return, create a branch. And if it falls, or is reachable. And this nearest item, create a branch. And this output, one is can, and another one is can. And if this reachable true, that it to can. If it false, it's can. If this true, can. And it's not valid, can. So let's save this, go to event graph, and call this Canvas tool. And use this nearest item. Connect it and connect to can. Connect to this. And we can delete this function. Let's duplicate this table and item. Move it here. And duplicate this static mesh. Rotate it 90 degrees. Move to the table. and this and this. We don't need to show name mesh. Disable this. And let's play test. Now when we go behind this wall and press E, we have the line trace. If this line trace collide, the character cannot go to collect this item. And if it not collide, the character walk to the location and collect the item. And another prevention, you can duplicate this table and scale this X to 5, Y to 5. And let's duplicate this item, move it here. And you cannot reach to this item. So let's press E, and now it's too far. We can walk to this. Let's delete this. This can walk to, blocked by mesh. We don't need this debug. Set it to none. And this debug path, we ignore this. If you want to debug, just connect it again. To make the animation look more realistic when we turn in place, I want to add the head turn a little bit when the character turn. We'll go to BPI anim and add another function. Name is set head rotation. And add input rotator. The name is angle rotation. And add input boolean. Set it to alpha. And save this. Go to ABP menu. This event graph. And we can close this function. Call event set head rotation. And promote this to variable. The variable name is head rotation. And promote this to variable. Variable name is head bone. And set it. Create a branch. If it's true, we set this rotation. If it's false, we don't set it. And this update animation, add another pin. Down here, we get head bone and create a branch. Connect it to this sequence. add another variable. The variable name is head alpha and set it to integer, a float. Get head alpha f interp 2. Target is 1. Get delta time. Get per data second. Set it to data time. And interp speed is 1. Let's set this head alpha when it's true. And when it's false, copy this. Like this false. Target is 0. Interp speed is 3. And compile. Go to anim graph. Call transform bone and connect it to this component post. Connect it here. Get head alpha. Connect it to alpha. And we don't need this translation and this scale. And this rotation, add to existing. Get head rotation and connect it to rotation. Copy this for another bone. This one, choose neck 2. And another one is blind one. And this alpha, we can divide it by 2. Make it to this alpha. Go to third person character. And this turn to item event. We collapse this as a function. This set actor rotation. Name is set actor turn rotation. And this name is turn value. Open. Get mesh. We get this mesh. Get anim instant. For set head rotation message. And this turn value we call map range clamp 0.2 to 1, and this range to 0 to 1, because the value we get from this timeline The lowest value is 0.2 and the highest is 1. And we want to map it to 0 and 1. Multiply, make rotator, connect to this yaw, and for turning right we multiply by 35 and copy this as it, move it here, connect it. And for turning left, we multiply it by minus 25. Go to event graph. And when we stop turn the item, get mesh, the character mesh, and get actor instant, get anim instant. For set rotation, set head rotation, and set it to this rotation is 0. And this one, the alpha is true. And go to event graph. This turn to door. We do the same. Set actor turn rotation function. Make it to Z value. And delete this. And when we stop, copy this. Anim instant. Set head rotation. And set head rotation to 0. And under the adjustment, I want to stop this, adjust this walk speed for the door when we go near the door. So let's delete this, compile and save. Let's play and go to this. And we can see the head of the character turn a little bit when it turn in place. Next, I want to add the widget to appear when we walk near the item that I want to collect. Go to third person and widget, add user interface widget blueprint, user widget, WB, Interact. Open it and search for canvas. This canvas panel. Overlay. Horizon. Call box. overlay, border, image under this border, and tag in this overlay, and another tag in the horizontal box. We adjust this overlay, anchor to center, and move it to center position. Line is 0.5 and 0.5. Size to content, and adjust this X position to 245. And this overlay, set it to fill. This border, let's set the image first. The brush image, we set this TUI PC key. Let's change this image size to 64 and 64. And this border, set it to horizontal alignment is filled. This vertical, and adjust this heading. This to 8 and 8 high. And change this brush color to throw alpha. And this text, set it to the text E to the center. And this font, change it to regular. Another text block. This text name is grab. And set it to this vertical. Change the font to Roboto Tiny Line. Size is 32. Compile. Now we have this widget. Go to graph. I forget to set this text. That is to variable. So we can call it from this variable. To add a custom ribbon, the name is set text. Add input, boolean, open, and create a branch. Get text block, set text. If it's true, change the text to open. This is for the door. And set text. If it false, hang back to grab for the item. And save. Close this WB Interact. To third person character. Add new function. The function name is add Interact Widget. And input is open. And call create widget. choose WB Interact and promote this to variable. The variable name is Interact Widget and get this Interact Widget is valid. We create this widget when it is not valid. And then add to viewport. Get Interact Widget for set tag. And connect it to open. Compile and add another function. Name is remove Interact Widget. Get Interact Widget variable is valid. And if it is valid, we remove from parent. And set Interact Widget to empty. To event graph, create a custom event. Name is request add widget. And another one is request create custom event. Request remove widget. Get door and all is valid. And only add the widget when the door is not valid. And then we get all item. Find nearest item. And this nearest item called can walk to. If we can walk to the item, we add Interact Widget. This prevents us from the item that cannot walk to and the icon still appear to the player. So copy this. And if it can't walk to, we remove Interact Widget. For the sphere, scroll down, begin overlap, and add overlap. Over here, and the actor has to BP collect item. If it's true, we get collect item and create a branch. When we not collecting the item, this will prevent it from player that playing the animation montage and this icon appear. So when it fall, we can request add widget and this add overlap request remove widget. Comment on this, name it to widget, and this collect item montage. After we collect the item, it's add notify. We call request add widget to search around the item that is there any item that we can collect it or we can grab it. When we press E and it fall, call remove Interact Widget, compile and save. Let's play test. We still cannot see this. Sorry that the widget not happen because this reachable. This item we should connect to this find walk to location. We don't use this nearest item. Let's compile, save, play test. And when we walk near this item, we have this grab, and when we walk out of the range of it, it disappears, the widget. And after we finish collect the item, if the item have the distance near it, it will show the grab widget. Next, we want this widget to open for the door. Go to third person character, event graph, and this event set new door. We call get door and is valid. If it valid, we add widget, interact widget, and set open to true for opening the door. And if it's not valid, we remove interact widget. Copy this. Display montage for opening the door. Pass it here after we set collision door. And these two. And go to the door, go to BP door, and this overlap to prevent the overlap. For tooltime, add the component. Check if it equal to player capture component. And create a branch. If it's true, we set new door. If it's not true, we don't set it. Go to third person character. I want to adjust this. Turn to door, event, and this value set it to 4 to avoid the error. Save all. Let's play. And here, when we near the object that we can grab, it show the grab. And when we near the door, it show open. Press E, open the door. And after we open the door, we have this widget again to open back. And let's check if it's working for this top location. It's still working. So thank you very much for watching. If you have any question, please leave it in the comment section below, and please subscribe to my YouTube channel. Thank you very much for my Patreon members who are supporting me. Your support really means a lot to me. See you in the future tutorial.